and welcome to this next video on OCR A-Level Chemistry. We are on Module 2.1, which is Atoms and Reactions, and this is the third video in this series. In this video, we're going to be looking at the mole. So, first thing we need to talk about is amount of substance. So, if we look here at amount of substance, so amount of substance is a quantity that chemists use for counting the number of atoms in a substance. So amount of substance is given the symbol N and is measured using a unit called mole, and it's abbreviated to mole, like that, MOL without the E. So the amount of substance is based on a standard count of atoms, and this is known as the Avogadro constant. Avogadro constant. And this is the standard count of atoms that we use. And that number, it has a number, and that number is, which is represented by NA, is equal to 6.022. I'll write the full number, but it's abbreviated to 6.022 14179 times 10 to the 23 moles to the minus 1, and this is abbreviated down to 6.02 times 10 to the 23 rounded to 3 significant figures. So that's the Avogadro constant. So a key definition is mole. So mole is the amount of any substance containing as many particles. I'm going to move my mic closer so you can hear me. As many particles as there are carbon atoms, as there are carbon, I'm going to write C atoms in exactly 12 grams of carbon-12 isotope. And another key definition is molar mass. So this is molar mass now. And molar mass is mass per mole. It's essentially mass per mole of a substance. Mass per mole of a substance. And the units are grams in mole to the minus 1. So I'm not going to write this next bit down because it's just a bit of extra info. So counting and weighing atoms. So use the definition of 1 mole, I'm going to read in the textbook, is that you now know that 12 grams of carbon-12 contains 6.02 times 10 to the 23. So because of it, the mass number of carbon-12, so if we look at here, I'll do a thing of it around here. So if we look at the carbon-12 like square in the periodic table, you may remember from the very first video we talked about that this is our mass number. So that's like 12 grams because the mass number is 12. So in 12 grams of carbon-12, that is exactly 1 mole. So this is technically the mass number is mass of 1 mole. And it always contains this number, 6.02 times 10 to the 23 atoms. So the mass number, for example, of carbon-12, the mass number of C12 is 12. So that tells us that there's 12 grams of carbon-12 in 1 mole. So 1 mole of carbon-12 is the equivalent of 12 grams. And that means that 12 grams of carbon-12 always contains 6.02 times 10 to the 23 atoms. So likewise, if we looked at the periodic table, which I'll splash up now, so if we look at this periodic table, and I'm actually going to look at the one in my textbook. So if we look at this periodic table here, so for instance, if we look at, say, fluorine, so for fluorine, you can see that the mass number there is 19. If you look on the periodic table here, you can see that fluorine has a mass number of 19, so that means that 19 grams of fluorine is 1 mole is equivalent to 1 mole of fluorine. So 1 mole of fluorine atoms, 1 mole of fluorine contains 19 grams. It is the same as 19 grams. So that means that 19 grams of fluorine, it has 6.02 times 10 to the 23 atoms. No, not atoms, molecules in this case. It's a little bit confusing. It's slightly confusing, but hopefully, oops, let me just find my page again. But hopefully, you'll start to build up that knowledge over time. Okay, going back to amount of substance and the mole. So you can have moles of anything. You can have amount of atoms, so a mole of C atoms. You can have amount of molecules, so for example, a mole of Cl2 molecules. Amount of ions, so OH minus ions. You can have 1 mole of oxygen could either refer to oxygen atoms, or which is represented by an O, or to oxygen molecules, which is represented by O2. So 1 mole of O, as in single mono, as in O atoms, or 1 mole of O2 is chlorine. That's what they're saying in the textbook. So we're just going to look briefly at just how big is 1 mole. So 1 mole, so it's a huge number of atoms in 1 mole. It's so large that it's almost impossible to imagine its true size. So we're going to have a look. So this textbook describes a comparison. So let's take, for example, if atoms were the size of drink cans, for instance, then 1 mole of drink cans would cover the surface of the Earth to a depth of over 300 kilometers. So even if you are able to count atoms at a rate of 10 million per second, which is impossible, it will still take you about 2 billion years to count the atoms in 1 mole of atoms. Also, they gave a really good picture in the textbook. I'll splash up on the screen now. Is that 1 mole of coarse sand, if you were saying atoms are the size of coarse sand, of grains of coarse sand, 1 mole of coarse sand grain will cover the entire surface of Great Britain to a depth of around 1500 kilometers, which is impressive. Anyway, now we're going to look at molar mass and how we can calculate molar mass. So let's have a look at molar mass. So I should have written molar mass. So we know that our definition of molar mass is the mass per mole of a substance. So for molar mass, it's a useful term and it can be applied to any chemical substance, whether it's an element or a molecule or ion or, I don't know, anything with any chemical substance, elements, compounds, any both types of compounds, elements, molecules, ions, you can apply molar mass to. So you can find the molar mass by adding together all the relative atomic masses for each atom that makes up the formula unit. So for carbon, so you need the mass number. So for instance, for carbon, if you find the molar mass of carbon, it's basically the mass number, 12, as we mentioned before. And for carbon dioxide, where did my pen go? So if we were to take the M of CO2, then you need to do some math. So we take the molar mass of carbon, which is 12.0, and then you take the molar mass of oxygen, but remember it's 2 oxygens, so we have to do 16.0 times 2. That will get us to 12.0 plus whatever this is, which is 32.0, and that will get us to 44.0 grams per mole. So in 1 mole of CO2, there is 44 grams in 1 mole of CO2. So the amount of substance, there is a formula for this. The amount of substance, which is N, and mass, which is small m, and molar mass, which is big M, are all linked by one formula, by a general formula. So it is, and I'll write it in red because this is every one of those formulas you need to memorize. So number of moles is equal to the mass, which is which is measured in grams, over molar mass, which is in G moles to the minus 1. And essentially that can be separated, linked, small, like abbreviated down to this. So it's N equals small m over large M. And if you rearrange that, you can find that small m is equal to N times big M. So these are some critical formula that you need. I think I have some word examples in my ChemCalc series. I'm gonna double check. If that is the case, I'll do a ChemCalc video based on this. But I'm gonna give you one example here. So if we take this example, which I'm doing in purple. So if we want to work out, for instance, the number of moles in, okay, and let me find a good one. I'm gonna check periodic table. So let's take nitrogen. Actually, let's not take nitrogen. Yeah, let's take nitrogen. Let's take nitrogen. So for an example, yeah, so we're going to do nitrogen. So nitrogen, a sample of nitrogen we have here. If I have a sample of nitrogen that weighs, what is the mass number of nitrogen? Hold on one second. Mass number of nitrogen is 14. So if we had 28 grams of nitrogen, so our mass is 28 grams, we know the molar mass of nitrogen, which is 14 grams per mole. We want to know how many moles is that. So what you would do for nitrogen, you'd write first in the formula, which is N equals small m over big M. So N would equal small m, which is 28, over big M, which is 14. So N would equal to 2.00 moles. And that's correct to 2 decimal place or to 3 significant figures. Then I will do a chemcalc video on this in the near future if people are still struggling with this kind of math, but it's a simple math. I will do a chemcalc video in the future based on this. Anyway, and yes, I think that's it for this video. So that's it for this video here. In the next video, we're going to be looking at types of formula. So thank you all very much for watching, and I'll see you in the next video. Goodbye.